Hello, and welcome to our next vlog or podcast. This will be the 51st one. Today I'm going to just briefly, we'll probably be done 10-15 minutes. Just kidding, it'll be a little longer. But in any case, today we're going to talk a little bit about what I was up to this past week, which was IEEE standards development. In particular, the Power Engineering Society's Material Subcommittee. I sit on a number of the standards, providing input. Pretty soon there'll be a PAR up there related to a standard I'll be chairing on surge testing, basically, of assembled machines. Right now there is no standard for that, but that's neither here nor there. That'll fall under the purview of PES Materials, because the PES Materials Group is responsible for all the material testing, so machine testing for condition of insulation systems and things like that. So let's go ahead and we're going to cover the standards we talked about this week and some of the other standards that fall under the PES Materials Group. Meeting was held in Pittsburgh at Siemens. And it was pretty well attended. A lot of OEMs, and calling in were a number of plants. We had another repair shop, so we had two of us with machine repair experience, some nuclear power stuff, and so on. A lot of hydro and that kind of thing. So part of my job, part of my responsibility in that group is to also represent, not just form wound machinery, but smaller random wound machinery, as is Dave McKinnon from PDMA. So he and I kind of keep some focus on technologies that we used to have a much larger presence for in the past in these committees. Now it's primarily large form wound equipment, big generators, and so on. So I'm going to go through some of the ones that we covered just so you know what's coming up. I'm not going to get into any details because these are not completed. Some of them are brand new, some of them are rewrites, but I'll just kind of describe what the standards are about. So P95, which has been around for a long time, is the recommended practice for insulation testing of AC machinery with direct high voltage. That is your high-pot test. Right now, based upon rules for titles and so on, descriptions, we may have to return and change this title a little bit. But this was the title that's been there forever. So it basically means that is the high pot standard or high potential test standard. A lot of recommendations for how to do it, how to, and so on and so on and so on. A lot of standards from NEMA to you name it, all reference back to it. There are equivalent IEC standards. That's not our topic today. The next one, where it says new, so revision means this is one that existed that we're revising. P1719, which is new, is a guide for evaluating stator cores of AC electric machines rated 1 MVA and larger. So good-sized machines, basically. So that'll tend to be your medium and high voltage machines, generators, things like that. And this is talking about the condition of the core itself and how to repair it. Why is that important? Well, as the newer and newer steels come out and a greater focus on reducing losses in machines, this addresses all of that. P1310, which is a revision, which is the recommended practice for thermal cycle testing of form wound stator bars and coils for large rotating machines. This was a fiery one because this one goes into not just how to perform certain inspections and tests on coils, especially if you're specifying like a generator or something like that. That's really what it's for. So you're going to see in this primarily your 6,000 volt and above generation, and that's what I mean by large rotating machines. So the OEMs were looking at it as wanting to make sure that there were tests that were not written in there in certain ways. We're looking at the possibility of having to make this a fairly educational standard as the new generation floats in. But it did bring up some interesting concerns, the discussion, and I'm not going to cite who or details, of course, because that's the purview of this type of meeting. You've got a whole lot of people in there, and it's a consensus standard, right? But one of the biggest concerns from all sides in this, end users, service centers, and the OEMs, was the fact that people will often not understand the standards that they apply. And I've run into that in the past too, including in IEEE Standard 519, which is a harmonic standard where somebody said must meet requirements of 519 about new inverters being put in. And when they were installed, and we ended up with a horrible electrical issue throughout the plant as a direct result of that. When we went back to the manufacturer, they pointed and said it meets the standard. Well, what we were having problems with was on these smaller machines on transformers that had high short circuit, but they were overloaded. Capability was that it basically allowed up to 50% harmonic distortion in current, all in the fifth harmonic, counter-rotating field. And contrary to what 519 says, every machine in that branch was absolutely affected. 4,500 horsepower synchronous machines that had 7-second startups had moved out to 11 to 14 seconds, things like that, because they were fighting that harmonic as they came up to speed whenever those machines were on. So I was the one who did the testing on the impact. In the end, the drives actually met 519 in total dynamic distortion, which is the current part, which is a relationship of the amount of current to the short circuit current of the branch. And 519 unfortunately states that, it doesn't affect anything else, it just goes straight back to the transformer, which we know is false. That's not correct information. So when you go out and you just say, okay, it must meet IEEE whatever, or IEC whatever, or NEMA whatever, if you don't understand the standards, you can't. You basically in the spec, that's your chance to tighten things up. Remember, these are consensus standards, and my opinion, based on fact, is that OEMs want to make sure there's as little in there that they're going to be forced to follow. And so they'll push back on things where there's testing that they feel, they don't think the customer needs to know that information. The customer wants as much information as possible. And the opinion was expressed that, well, they don't actually use that information. But as a reliability engineer, I know that, yeah, we do. But if you have a specifying engineer or a purchasing department that just says must meet this standard, but doesn't specify anything in the standard or misses that there's certain things in the standards, that becomes a concern. So in 1310, there's a list of tests that are performed at different stages of thermal cycling, and they're not necessarily required tests. They're tests that are used to get certain information. And if you say, I want to use 1310, or you must use 1310, the implication there is that could mean that you are going to perform all those tests, and you might get false positives or negatives on the condition of the machine or coils. So often those tests are performed, but they're performed and then recorded for later information. So that one was was interesting. I'll probably cover some of these independently a little more at another time. But next one was 3149, which very happy to be a contributor for. This is a new standard. And it's going to be extremely important for those of us who do electric machinery root cause failure analysis. As a matter of fact, yesterday, after driving back 8 hours after leaving the site where we were doing the work till 4 o'clock, so I got back about midnight. Then I had to go to a get-together at one of our clients, a motor repair shop. And they brought me in. They said, "What do you think happened here?" Well, based upon the work we're doing, the dissection thing, I said, "Well, that happened first, and then that happened." So that was very important, because then the OEM happened to be there because it was a concern, and we said, "Okay, here's some ways to fix this." Well, we've got a bunch of those in the field, and they aren't failing. Okay, well, great. If they do fail in the same way, and they come in and they get rewound, add this. So this trial use for dissection, some of the stuff I had put in there related to salient pole machines, so the actual DC coils as well as some of the other stuff. I think we put that in as an annex. Form coils, how to cut it, how to clean the surface so that you can get accurate information on voids, breakdown, et cetera, et cetera, et cetera. Basically, how to get the information, and then the process for how to view the information. This has been going on for a while. As a matter of fact, the PAR request was 2022, and we're well into it. It's still got a little bit to go, but I'm already following the standard for the work we're doing, and then I give that input as we go on. Now, next one is one of probably industry's most important standards. That is IEEE Standard 43. The P means that it's in process, or that stands for PAR. That means that we're working on that standard right now. So this just means that this is a draft standard that's being worked on, reassembled. Now, what happens in this is the committee gets together. We could literally take the standard, throw everything out, and completely rewrite it. That's always a possibility. Now, what I see in 43 is people are still referring to all the work in the IEEE 43 1974 standard, which was updated in 2000, which became very specific on a lot of things. Reissued again in 2013. Those who look at it and say the Arrhenius equation, 10 degrees centigrade means double or half the insulation resistance value, has not seen anything since the IEEE Standard 43 1974. So it's changed a lot over time. We're working on it again. We're tightening up some of the curves. There are formulas in there and so on. And actually, references back to 1974 came up because this standard used to have a section in 1974 about how to dry an insulation system. That's no longer there. So that was part of the discussion. Do we want to bring that back? Because newer people coming into the industry won't remember that stuff or won't access stuff. They're going to access the new stuff, and all that educational stuff that we had from that period of time is gone. So we're going back to some of those historical documents. I think, matter of fact, I'm one of the ones responsible for seeing if I've got a copy. So 43, standard for testing insulation resistance of electric machinery. Now, what's also interesting is we see people refer to cable testing and other testing, and then they say, reference IEEE 43. Well, in reality, you can't, because IEEE 43 is meant for electric machines. There are other standards, including the IEEE 400 series. NETA has some tables. I just did an article on this that I'll talk about briefly at the end for NETA that comes out in about a week. So that one is being worked on right now. There was some, fuss going on because, again, some of the original the OEMs, motor manufacturers don't really want people doing polarization index and other testing. So we had to remind them that those tests are being used in the field. They are actually being used by people still. So we have certain statements that exist in 43 since 2013, and now that same fight's come up again. Okay, so the next one, 1553. This is primarily for hydro generators. This is endurance testing of form-wound coils. Well, they're slightly different shape than a standard form-wound coil. So we have different stuff going in for that. I'm not as involved in that one. I have some input in there, but I usually, when we have our face-to-face meetings, the ones that I am involved in, normally what we end up doing is in between, because we only meet twice a year face-to-face, in between we'll have teleconferences and the like to cover this stuff. So next one is one I'm very involved in, and this one Dave McKinnon chairs from PDMA, and it's P97. I'm sorry, he's involved in as well. I'm sorry, Helene is the chair for that one. So P97, this is where we moved from 43, some of the specialty testing, like the insulation resistance profile. We've moved that there. So Dave and I are specifically working on that. Some of the areas I've been involved in is the impact of cable length on insulation resistance testing and how to respond to that. That stuff's in there. Then we also have absorption, desorption in there, and so on and so on and so on. Somebody suggested surge testing in there as if it were a DC test, and it's not a DC test. But that's neither here nor there. So the concept here is basically a list of all the different types of primarily DC testing of electric machinery. Electric machinery became the definition for both motors and generators because we were doubling up standards in the past. 62.2, one of the really, really serious standards that people often forget. This is the Guide for Diagnostic Field Testing of Electrical Power Apparatus or Electric Machinery. So this standard here lists out all the more common tests. I had submitted a statement on electrical and current signature analysis, but I had submitted it late. I didn't realize this was... it had been, I thought it had already gone through, but apparently it was kicked back after voting because I tell you, electric machinery testing is a very divisive field. A lot of people, say this technology can't do something, et cetera, et cetera, et cetera. It's one of the reasons why IEEE 1415, after we came to a consensus, got basically allowed to be administratively withdrawn. What by the way, to go after the scammers who tried to tell people that 1415 was thrown out for all of these different reasons, and that was the period that I was chair, because my job was to chair the transition. I'm probably the horse's mouth that knows why it was retired. So there were some people that complained about certain testing because it conflicted with their sales. And that was part of it. The other thing that I had agreed with was that it had become more commercial than what it was really meant for, which it was supposed to have troubleshooting charts for electric motors, basically, and generators, and recommended tests you went through. The other problem with the commercial part was because certain instrument manufacturers pushed back hard, is that individual tests for each type of technology had to be broken out instead of saying, this style of testing or this style of testing. So it became pretty, it was an aggressive issue. So we allowed it to be what's called administratively withdrawn, which means it's still a standard, just nobody sat down and said we were going to put out a PAR to update it within the 10-year time period required. So, it's not done. It's not an invalid standard. That's a different type of withdrawn. So there's administrative withdrawn, and then there's withdrawn. Now, in withdrawn, that means the group got together and said the testing is no longer valid, and voted to have it removed. That's not what happened with 1415. But that's a slightly different group. That's PES as well. And from what I understand, there's a bunch of us that want to be involved in the upgraded standard, but it was taken over overseas, and let's just say it appears that they don't like some of us to be involved in that. They want to handle it so it's more focused on what's available in their country. That's my personal opinion, because I've had a couple of standards where that type of thing has occurred for political reasons. People do things because standards are important. So, for instance, IEEE 1068, somebody suggested that I didn't need to be involved because another organization involving motor repair was involved in that standard. So they put into the standard that electrical and current signature analysis couldn't be used on unloaded motors, based on nobody with any understanding or knowledge of the technology, just that it was detecting defects in the process, and they did not want that to happen in their client base. So I've been writing a series of articles pushing back on that crap, because it's crap. It's dishonest, it's unethical, but that's the way it is. You'd think these organizations would be ethical in some way, shape, or form, but not necessarily. I'm just not part of the good old boys club. I never have been, don't like it. That's why you don't see me masked up with all these different groups, or my company, because I believe in supporting other technologies. I don't believe in ganging up to try to exclude others from industry. So, more power to them. I'm really happy with the level of sales we have, and we do not discuss who our clients are, but they're big and there's a lot of them. So in any case, so P62.2, getting back to this instead of being off of my soapbox, P62.2, this is a very important standard. This one I will probably cover as its own in the near future, because this is out for ballot right now. So I already signed up for it. So the near future, I actually in June we'll know if it passed or not. IEEE 1043, recommended practice for voltage endurance testing of form wound bars and coils. Remember, this is not random wound, this is form wound. We're looking at bringing back, Nancy Frost actually recommended bringing back another one on doing random wound coils, which is really important because that'll cover electric vehicles and the like. So in anyways, 1043, recommended practice for voltage enduring testing of form wound bars and coils. That's to gather information on whether insulation mixes and so on will pass, and this is also something that can be specified in the manufacture of a machine. You have to remember, as you specify some of these things, that will have a direct impact on the cost of building it. And then one of the really important ones, so recommended practice basically means should, standard means you will, and guide means it's information, right? So this next one is the guide for measurement. That's 1434. Now this is an existing standard. 1434 is the guide for measurement of partial discharges in AC electric machinery. So this is your partial discharge standard. So these are the ones we worked on the last couple of days because they're the ones that are actively there. And then at the very end, we had our meeting to go over anything that needed to be covered before it ran out. So let's take a look. 2465 IEEE trial use recommended practice for pulse type partial discharge measurements on individual stator coils and bars. Well, what is a trial use? A trial use means that they put the standard together based on a relatively new technology, one that doesn't have a lot of information behind it, and I'll get into that in a second. And then you put it out there for 3 years. So once it's authorized, it goes out for 3 years, and then you come back and revisit it so that people have a chance to use the standard and then come back with discussions related to it. Now, this is relatively new, so I'm going to be, this shouldn't be right because it should be 2026. So I'm going to be looking at this standard later because I actually use the IEC standard for offline PD testing, off of a surge tester, and that's basically what this is. So this is equivalent to the IEC standard that we use for, the Baker instruments and Electrum, and the ones that have offline PD test. And there's some specific offline PD testers only for repetitive pulses. So these are the ones where you have your surge tester, you clip it on, and it'll also give you PD inception and extinction values. 1434 IEEE guide. Oh, there it is. Okay, so it's still active for the measurement of PD. So that's still active. 56. This one here is we've been discussing that, but I don't think it's not in active work right now. But we're warming up to it. So the work surrounding the PAR submission for updating it is in process now. So it takes years to get these done, by the way. I think we've got some. You can take up to 8 years to develop a standard. IEEE, that's because you've got to get consensus from almost 100% consensus from everybody. And I say almost because people can go through and throw your comments out. I had that experience with a different standard where I then had to argue with IEEE and have my name taken off that standard because somebody in the chair and another person in the group were anti-clean energy, and they made sure to populate the standard with anti-wind and anti-solar stuff, and it was absolutely false information. There are standards written around everything. So it was a group of people. It was on commercial and industrial building electrical systems, and I was the only one who had clean energy experience. And any time I countered their argument with fact and information and existing standards, they pushed back and said, well, my buddy said, and we read it in Forbes. At which, again, I could go on my soapbox on that. Because to me, that invalidated any use of that standard. It's a joke. There were 200 people involved in that standard. Not a single person, and it was global, not a single person did it, but they believed this guy because, he would come back and basically state that I had agreed with him on stuff, and especially if I wasn't in that particular meeting, and then in the next meeting, no, I didn't, and then it became I was accusing him of lying, and I said, yeah, I'm accusing you of lying, and they didn't like that because that would have required him to go up on an ethics committee thing, but that's neither here nor there. So I just had them take me off the standard, and it's unfortunate because that was an important standard in the past. Anyways, IEEE 56, IEEE Guide for Installation Maintenance of Electric Machines. Very important standard. It includes a lot of visual inspections. My pushback on some of the discussion we had on releasing it had to do with the fact that somebody had mentioned something about if all the other tests passed and you slice up the sample bar, you open it up and it's defect, and you find a defect in there. Well, how can you condemn everything because it passed the test? And I had to remind everybody the visual inspections are more important than electrical tests. So that's kind of it. 117. This one here is a random wound testing standard. This is one of the ones that Nancy Frost brought back up along with 286. IEEE standard test procedure for thermal evaluation of systems for random wound AC electric machinery. There was basically the thought that we didn't need to do that, and then I mentioned that UL still utilizes this standard as part of their work, as well as a 286. This has to do with how do you rate the insulation system. And the OEM pushback was, well, what if somebody just squeaks by and somebody else is well within? And it's like, well, that's where you have to have that information available. 433, IEEE recommended practice for installation testing of AC electric machinery and high voltage rating up to 30 kV at very low frequency. This is the famous VLF test, in which somebody was trying to explain to me recently was not, did not exist as a standard, and I said, yes, it does, and here it is, 433. And then 522, people mistake this, because it's the IEEE guide for testing turn insulation of form-wound stator coils of alternate current electric machines. People often mistake this as the surge test standard. And while surge testing is definitely part of it, but not for a complete machine, only for individual bars. And I'll outline green bars, meaning uninsulated bars, or pre-VPI, or wet wound, not dried yet, versus individual bars or small groups. This is where 522 comes in. It's a quality assurance inspection of coils. It is not and never was meant to be a surge test standard for assembled machines. 286 is the IEEE approved draft recommended practice for measurement of power factor tip-up of electric machinery stator coil insulation. I apologize. That number used to be assigned to something else. This is power factor tip-up. This one here is going to come up soon to be reevaluated. 1799, IEEE recommended practice for quality control testing of external discharges on stator coils, bars, and windings. Basically, corona and other testing and other things related to damaging coils, bars, and windings. Now, when we talk about coils, bars, and windings, in this case, we're primarily talking about form-wound coils. The majority of the group, and our group may have anywhere from 25 show up to 75 or more. We have noted, by the way, that there's a growing number of non-gray-haired people showing up. Some of the people that have retired or passed away that were involved in the group have been replaced by their companies or others to represent that particular stake. Just so people are aware, anybody can attend a standards meeting. Next one for this group in person is going to be at the Electrical Insulation Conference. Basically, we'll be at a really cool resort in the summer, so that'll be fun. I've submitted a couple of papers on the research we're doing, so hopefully we'll get those published as well. But that's kind of a quick overview. There's more standards, but this group here are the ones we worked on this week, and I said I'd do a very basic report. And there's some of them that we're going to go into in detail in the near future so you understand what they are. Do know that a lot of IEC standards are equivalent. They have slightly different rules. You can find IEC standards that are very heavily OEM, and that's allowed. In IEEE, when it goes up for vote, there has to be a mix of different people, and that is a required mix, meaning that you cannot have an OEM or end user dominant standard. It just can't happen. Now, then we harmonize between IEC and IEEE over time. Both sides kind of give a little bit, although it's difficult to get the IEC folks to give much at all. But the IEEE standards, these are what NEMA follows, National Electrical Manufacturers Association, and some of the people that sit in the standards also sit on those standards, including myself. So I was recently asked to participate, and unfortunately the last meeting for this was exactly while we were having this meeting, but on rail electrification, meaning big rail, not your local like subway and stuff like that, but we're talking about the big heavy trains, the electrification standards for that. In any case, that should cover it. If you have any questions, please let me know. If you have comments where you want to have me cover some detail on a particular standard in an upcoming podcast or vlog, I technically these are vlogs. I'm not interviewing people, but let me know, and I'll see if it fits in the schedule. With that, thank you very much. Have a good one, and we'll talk again next week.